Thanks a lot for coming to my session this morning. Really appreciate the efforts, especially given that it's the first session after the big party the night before. I was struggling a bit to get up this morning, so yeah, really do appreciate you coming along. So as the slide says, my name is Nick Westbrook, and I'm an infrastructure consultant at Provoke, as well as a Microsoft VCSP for Windows Azure. So I've been working with Windows Azure for about the past 2 years now. And I've been lucky enough to be involved in building some pretty cool projects for some of our customers. For example, you probably would have seen the All Blacks app that was demonstrated during the keynote address. Yeah, it's really cool to be able to bring the power of Azure into solutions that we can deliver to our customers. But in addition to customer solutions, we actually use Azure quite extensively in-house at Provoke as well. Predominantly to increase service availability to our international offices, as well as keeping infrastructure costs down. So today, I'd like to talk to you about Windows Azure in the enterprise. I'm going to be running through a couple of the Azure services that we use at Provoke, give you an idea of how we use them, and hopefully give you some ideas as to how you can actually use Azure as your own data center. So to cover that, I'm going to be running through 3 questions today. Firstly, why cloud? So why would you actually want to put your services in the cloud? Secondly, why Windows Azure? So what makes Windows Azure a pretty good choice as a cloud services provider? And thirdly, how can I use Azure in my company? Where I'll be running you through a few scenarios and showing you ways that we've actually used Azure at Provoke. So firstly, why cloud? Well, there's really 3 driving forces behind the adoption of cloud today, those being speed, scale, and economics. Now, speed is more than just the performance of the actual machines that you'll be running up in the cloud. It's also the speed of provisioning these machines, building them up, tearing them down, and also the delay that it usually takes to actually get a machine up and running. When you find when you go to the cloud, that delay shrinks down to next to nothing. Along to scale. Scale includes things like how easy it is to deploy 1,000 instances of a machine if you really needed to do that. And also scale also includes reach. So a lot of us have data centers here in New Zealand, but what about if we have customers around the world, or if we have other branch offices around the world? Deploying into the cloud really allows us to leverage that global reach to deploy our solutions close to where our customers actually need them. And thirdly, economics. This is a pretty key factor in cloud adoption, in that you actually only have to pay for what you're using, exactly when you want to be using it. So there's no need to over-provision resources to cater for worst-case scenarios. You can build it small and scale up exactly when you need it. If you don't need that capacity anymore, it's really easy just to scale down. Included in economics as well is obviously there's some pretty low barriers to entry. So if you're a small company starting up, you really don't want to be going out there spending hundreds of thousands of dollars on STAN equipment and your own servers, when a lot of that functionality can actually be produced straight out of the cloud. So yeah, some very key points driving cloud adoption at the moment. So in addition to the benefits that cloud provides us, there are obviously also a few challenges as well. First of those, you could say, well, how does cloud integrate with my existing IT investments? So if I've already gone out and bought our own data center equipment that's sitting on premises, why would I want to go out and actually deploy some stuff to the cloud? Well, that's a pretty key thing to keep in mind. And also you want to make sure that the way that you interact with your equipment on premises is pretty similar and aligned to the way that you use it in the cloud as well. Because otherwise you get that bit of disjunct where you have like one team managing cloud stuff, one team managing your on-premise stuff, and it just gets a bit confusing. So in choosing a cloud services provider, you really need to make sure that the way that their cloud works is the way that you work internally as well. Second challenge, what about my mixed IT landscape? So while Microsoft may love and hope that you use their entire stack for everything, there are quite a few companies out there that actually do run Linux machines. You may run Oracle databases. So it's purely not just a solid Microsoft-only solution or one vendor-only solution. Choosing a cloud services provider, you really want to make sure that they support a wide range of solutions that you use. Thirdly, probably most importantly, quite a big one, what about security and compliance? Obviously, when you have your own equipment and you're in charge of whatever you're doing on premises, you can be very stringent in your security requirements. You can control access to who actually gets into that environment and not. You know your sort of passwords and security stringency around that. So you really want to make sure that your cloud services provider has at least the same level of security stringency as you do. You want to make sure that they're audited and transparent in what they do, so that you can actually have some trust with them. Because you're entrusting them with your precious data and your critical workloads, you want to make sure that they'll be looking after it for you the way that you would look after it yourself. So we've seen a couple of benefits and challenges to cloud migration in general. So first being, one of the first benefits is it allows you to focus on your service and not managing hardware. Secondly, you pay for exactly what you need when you need it. Third benefit, it's really easy to deploy, tear down, and change scale in an instant. But we have to keep those challenges in mind as well. Does the cloud service work with what I've already got? Is it stable, secure, reliable? And can I really trust it? So keeping that all in mind, answer our second question, why Windows Azure? What would make Windows Azure a really good choice as a cloud services provider for you to trust your enterprise data with and workloads? Well, before we get on to why Azure, it may pay just to give a brief overview of what Azure is. I know a lot of you probably know this already, but in case there's some people in the room that are wondering what Azure is all about, I'll give you a brief overview. So essentially, Azure is a collection of cloud services from Microsoft. These cloud services are highly scalable, flexible, and very robust. So you can see that from the diagram, the cloud services are essentially grouped into 3 different levels. We have our infrastructure services, data services, and app services. You can think of each of these services as a building block to put into building an entire solution for you. So the infrastructure as a services, or IaaS bit at the bottom, is probably what most of us are very familiar with. Sorry. Because most of us, I think we're probably IT pros in the room. So we deal with virtual machines, virtual networks, VPNs, that sort of stuff all day. It just makes sense to us. The bit that we're not that familiar with probably is the PaaS, or Platform as a Service options. So Platform as a Service is where you really get the cloud benefits, locking in things like immediate scalability and almost infinite flexibility. Because you don't need to worry about the underlying infrastructure. You basically just instruct Azure or a cloud service provider to do what you want it to do, and it scales out and handles all the grunt work in the background for you. So, for example, if we were going to build a web farm using the traditional IaaS methods, we'd have to start off with building a network. So we'd deploy a virtual network. We'd have to deploy a SQL Server backend, which could take a while to set up. Then we have to deploy our front ends. So start with one box, and if you think that perhaps in a few weeks' time you'll need a lot of capacity, you probably want to start planning for that up front and deploying some new machines, maybe get them ready, turn them off until they're ready to go, but it's quite an effort usually. And you have to worry about all other mundane tasks as well, like manual configuration of each of the machines, worry about like Windows patching, SQL Server patching. There's a lot that goes along with that, and security issues like antivirus. So even though IaaS gives us a lot of flexibility to do pretty much whatever we want to do and host whatever workload we want up in the cloud, it doesn't actually lock in a lot of the benefits that the cloud services actually do provide. So contrasting that, if we actually had to deploy the same service with Platform as a Service, what we would do is deploy a SQL database. You saw during Scott Goo's presentation at the keynote how quick that was. Sort of within a couple of minutes, you have a database ready, good to go. No need to build the server around it. No need to worry about underlying security issues and all that. It's just good to go, and it's ready for your use in a couple of minutes. In addition to that, we just build a website. So we use our website service in Azure, deploy our site to it, hook it up back to the SQL database with a connection string, and boom, we're good to go. If we think that traffic is going to be increasing within the next week or so, we really don't need to do much about it right now. When it does increase, it's easy enough just to scale that out and produce multiple instances of our website. And Azure actually has a service called Autoscale, which you've probably seen as well, which allows that scaling process to happen pretty much automatically. You give it some parameters that you want it to be in, and that ensures that your service is always running at peak performance whenever you need it, and you're saving money by not having to over-provision for data that, for a service that you don't really need that level of serviceability. So, onto Microsoft's hybrid cloud platform. So, one of the key features of Windows Azure is it's one of its key design principles, and that Microsoft really wants to give you a consistent experience with what you do in the cloud and on premises. If you're deploying virtual machines, using databases, developing stuff, working with identity services, Microsoft's goal is that the way that you do that on premises should be very similar or the same to the way you do that in the cloud or at another service provider. So you could be running any of your own equipment on premises using your own Windows servers. You could be deploying up to Azure or at another service provider using, for example, Windows Azure Pack. Don't know if any of you went along to Stu Fox's presentation yesterday. It was pretty cool, interesting. Essentially Azure Pack allows you to take the experience that you get in Windows Azure Online and bring that on premises or at your service provider. So the way that you interact with machines online and on premises is pretty much identical. Also, the tools that Microsoft has that you're probably using at the moment, things like Hyper-V, any Hyper-V machine that you're running on premises at the moment, it's really easy to just shift that up into the cloud, turn it on up there, and it just works. There's essentially no difference. SQL Server Management Studio, if you're using that at the moment to connect to your on-premises SQL Server databases, it's exactly the same tool that you use to connect to SQL Azure databases. It's just really easy. You don't need to worry about changing tools. It's a single consistent platform and a single consistent experience. So it's the question of scale. Microsoft currently has Windows Azure around in 8 data centers around the world. And you can see that it gives us a lot of ability to actually deploy our service wherever we need it to be. If you have customers in the States, you can use an Azure data center in the States to deploy a website close to where they are. Or if you have a branch office in the States, it'll probably be a lot easier and give your users in the States a much better experience to actually have some servers located close to them rather than having to constantly come back to New Zealand to get the data that they need. Using Azure as well as your service provider actually gives you a consistent experience again in that you don't need to worry about dealing with separate cloud providers all around the world. You don't need to, say, for example, do some research in the UK as to what a good cloud provider would be. If you're already using Azure for your services down here in New Zealand, it's the same experience just to deploy out into the States. And some pretty good news for us in this part of the world. Microsoft's announced that 2 data centers will be joining us, being deployed in Australia, probably, and will be online next year. So that could also allay some issues around data sovereignty. If you're more trusting of the Australians to look after your data than the Chinese, it's up to you. It does come up in conversations quite a lot with customers as to where their data is actually stored. So storing it closer to us over in Australia could allay some of those fears. So, on to our third question then. Oh, sorry, question?
Do you know when the data centers are coming online?
When they're coming online? I think second quarter next year, from what I've heard. Yeah, so second quarter next year, you can expect that to be there. So now we've had a overview of cloud in general and sort of Windows Azure specifically. We'd like to go into some case scenarios. So how can I actually use Azure in my environment? Well, I'm going to run through 3 scenarios with you today. Firstly, using Azure to store your data in the cloud. Secondly, to extend your infrastructure. And thirdly, to expand your reach. So into my first scenario. We've probably all seen graphs like that before. A lot of us in the room would have endless nightmares currently in our environments with the amount of data growth that goes on. A lot of studies have gone into studying how much growth occurs in data environments. The likes of IDC and Gartner have said that data compounds by, I think, like 60% annually, which is pretty high. And us in our own environments, we need to make sure that we can actually serve our business and cater for that growth. But that usually means having to sort of buy extra SAN equipment and extra hard disks and all the manageability that goes around with that, worrying about backups, and it's really quite a mission. The interesting thing, though, is that even though data growth does sort of go exponentially like that, the amount of data that we actually use is only about 20% of all the data that we have. So there's this chunk of data, sort of around 80% of data that's just sitting there on our hard disks, on our SANs, in our environments. And we're constantly having to worry about this. So instead of having that in our environments when we don't really need it, we can see that it's a pretty key opportunity to move that amount of data up into the cloud. If we don't need it highly available currently on premises, we can just shift it away. We know that it's going to be perfectly safe up in the cloud, but we don't actually need to worry about buying extra hard disks and constantly increasing our storage capacity on premises. For example, cloud storage currently in Azure, to store 100 gigs of data in Azure costs approximately 10 Kiwi dollars a month. So it's really cheap. Cost isn't a barrier to cloud storage. So you may also be wondering about high availability. How do you know that, sorry, I'll get questions after this. How do you know that your data is actually safe in Azure? Obviously, on premises, you've got RAID arrays, and you can make sure that your data is split around, and that there won't be any issues if you lose. There's like sort of no single points of failure. Well, for every piece of data that you upload into Azure, say, for example, from New Zealand to the Singapore data center, when it arrives there, the Azure Fabric actually produces 3 separate copies of that data. So even if one of their storage clusters fails, there's another 2 copies available, and these fail back automatically, so you won't even notice that there's been an outage. And this level of redundancy actually doesn't cost you anything either. It's all included in that initial price. If you want a higher level of redundancy built in, you can actually tell the Azure Fabric to mirror that data to a sister data center. So the sister data center of Singapore is Hong Kong. So that's enabled through a feature called geo-replication. So when it arrives in the Hong Kong data center, your data actually gets copied a further 3 times. So in effect, you've got 6 copies of your data sitting out there. So the chances of all of those going down is pretty remote to none. So you really have no worries about whether your data will be available to you when you give up sort of control of it, sending it into the cloud.
So what's the cost of the application?
It's a little bit extra, but really nothing much at all.
Oh, it's not double.
No, it's not double. No. Yeah. You may think that's 2 cents a gig more. There we go. For the geo-replication. So it's really nothing. So yeah, you may think that the whole deal about moving your data into the cloud would be a manual process. You can absolutely do that. Set up your own storage accounts up in Azure, copy whatever data you don't want on premises, move it up there, and it'll all just sit there happily forever after. You don't need to worry about backing it up or anything. It just works. If, though, you want to have active data management on premises, there's an awesome device called StoreSimple, which Microsoft acquired this company a couple of years ago. And what it does is essentially it's a SAN system. It presents itself as a regular iSCSI SAN for all intents and purposes, which provides the usual sort of SAN features like tiered storage, deduplication, and everything else you'd expect. But one of the key features of StoreSimple is that one of the tiers it has is actually a cloud tier. So it can automatically work out which bits of data you regularly access, keep those on fast SSDs inside it. The data that you don't access all that often, it'll automatically tear down to its SATA disks. And then any other data that you really don't need to use, or it notices that you're not using, it'll actually send that up into Azure, where it's perfectly available. You can still see the data through StoreSimple. So if one of your users actually wants to get to it, they just go to it as normal, and it'll just download it. Christian?
So Store Simple is an appliance, effectively?
Yes.
Has Microsoft any intention of building that into storage spaces as yet?
Probably Ben, do you want to answer that? So the question was, is Microsoft have any intention of building Store Simple into storage spaces?
At this stage, I don't know of any intention at this stage. I mean, logically, it will be a progression in the future. Right now, there's a lot of active development around Store Simple with re-platforming, also hardware releases over the next 12 months or so. So it's a key area as well. There's not any short-term moves talking about making a replacement in these spaces. It's actually not validated for that right now. So you can't just put Store Simple box in and have it as a low as a free space to actually be validation down to.
Cool. So I'll get questions after this. There's a lot of reading online, some awesome case studies if you head over to the Store Simple website. A lot of them relate to sort of American experiences of it, but if you get hold of your local Microsoft representatives, they'll absolutely give you some local case studies. One of those that I can personally vouch for is us at Provoke. We implemented Store Simple late last year, predominantly because we were running out of disk space quite rapidly, and it was quite a mission having to back up all of our data all the time, especially for data that we didn't really need to use. So we put Store Simple in, and currently we have around 150 gigs of Azure storage used by Store Simple, which only costs us about $20 a month. I hear from Ben that 150 gigs is quite a small amount, taking into consideration all the case studies they have. But we are just a software development house, so we're not like an engineering firm that would have like massive amounts of data getting generated all the time. So,
Do you know what it costs you for the Store Simple box?
I'm not 100% sure. Ben, again, have you got retail pricing? So the question was, how much does a Store Simple box actually cost?
Well, it costs, the way it's sold is through an Azure commitment.
Right.
So Provoke are actually going to go and buy Azure anyway. Yeah. And they have a storage problem where I have got some surgical Store Simple. I was going to so it actually worked out quite well that way. The way it was set up is through an Azure commitment. So you get your full Azure commitment. You just get anything that's been talked about.
Cool, yeah. So it's pretty compelling, and it's an awesome option for cloud storage. Okay, so you've had your hand up a bit.
Quick question, with the geo-replication, right, so it's all about availability, essentially. But as we've seen, networks, a big deal with availability in cloud. Do you get any network redundancy? So if we replicate it to, say, Australia, and have it replicate to Asia as well, we have network issues to Australia. Is there any smart network redundancy going on?
So the question was, with regard to geo-redundancy, even though the data gets a second copy in a sister data center, if there were any network issues between your primary data center and your premises, would there be any failover to the other data center? As far as I know, no, because the connectivity between your environment and Windows Azure, sort of Azure wouldn't actually know much about that. And also the geo-redundant failover is a manual failover process which Microsoft implements. Yeah, the high availability within the data center happens automatically.
So you would never connect to the replicated one?
No. Yeah, so if there was a data center failure, Microsoft would handle that failover. So, last question on this, yeah?
Can the data be encrypted with no private keys?
Yeah, absolutely, yeah. So the storage up in Azure is just purely storage. You can do whatever you want with it. You can encrypt the data on premises, send it up. Store Simple actually encrypts every packet that goes up to Azure Storage as well, and that's all built in as part of the package. Cool. So briefly, I'll just go into my first demo of Azure Blob Storage, just to give you an idea of sort of what it looks like in the background. So here we have our Azure Portal, which most of you have probably seen plenty of times now. To set up a storage account, you just head along to our new button at the bottom. You go along to Data Services, Storage, Quick Create, and we just give it a name. So let's call this TENS Demo Store. This location affinity group down here essentially asks us which of Microsoft's data centers we actually want to host the storage in. So you can see you can choose everything from East Asia through to Europe or the West US, East US. The affinity group at the top is a group you can create to essentially tell other services that they should be near each other. So, for example, if you've got the underlying storage hosting your VHD files for your virtual machines, you would really want the compute virtual machines to be close to where your storage is. So I'm just going to select a affinity group I set up before, and you see that here is the checkbox that says Enable Geo-replication. So even though you can uncheck that, I mean, for an additional, was it 2 cents a gig, it's really not necessary. You may as well have that extra level of redundancy built in. And then we just say go. So that will take a couple of seconds to create, but there is one that I've created earlier called TENS Demo 1. So you can essentially think of TENS Demo 1, my storage area, as a giant infinite hard drive up in the cloud that you can do whatever you want with. Just like a regular hard drive, though, you probably need to partition it before you can actually put some stuff in it. So these containers in Windows Azure, you can essentially think of like partitions or just big folders. So to actually use this, we have to use a third-party app to connect into Azure Cloud Storage, because it's not sort of intended to be like a link into your Windows Explorer environment. It's predominantly used for other applications to store data in, like, for example, Store Simple, or for storing your VHDs for your virtual machines. But we can still actually get into this through a third-party app. So if you head across the dashboard here, and you'll see this button that says Manage Access Keys. If I click on that, you'll see I have my storage account name and 2 access keys that I can use to get into the storage. The reason for the 2 keys is that you can actually cycle them around if you think that it's time to refresh your key, to make sure that if someone has randomly come across it, you can sort of revoke that key and generate a new one. But that would obviously cause an outage in your service if you did that with only 1 key. So you can change over to your alternate key while you're regenerating your first key and then swap back again. So I'm going to use a product called Cloudberry Explorer, which you can get off the net. And I'm going to go add new Azure Blob storage account. Display name, let's call it Demo. The account name, I'm going to paste in my account, TENS Demo 1. And then I just head back into the portal, and there's my primary access key. I'm going to copy that. Go into here, paste it. That's my shared key. Test connection. Connection success. We go close, OK, and boom, I'm into my Azure storage environment. So you can see here 2 containers that I've set up before. If you want to make an additional container, it's easy enough. Click on that, say demo, and you can see we have 3 access control options. We have full public read access for blobs only, or no public read access. So here I'm going to say no read access, go OK. It's created my container for me. Go into there, you see there's nothing inside it at the moment. If I want to upload something into there, I just go to my machine, find any file I want, say install exe over here, drag it across, copy the items, it'll upload 22%, 100%, and boom, it's in there. So as you can see, you can actually sort of use Azure Storage as your own sort of SkyDrive, but it's not really intended to be used that way. For example, if I look in my VHD containers, you can see here's 2 VHDs that I have for virtual machines that I'm running in Azure as well.
Tell me what about the deduplication is happening?
No, it doesn't. Yeah, that's internal. Oh, sorry, the question was, does it tell you how much deduplication is happening? So yeah, that's internal Fabric stuff.
You're paying for the 127.
No, you don't actually. So you only pay for the amount of data that you actually use. So as you know, with VHDs, you can create a sparse disk. So even though it appears 128.7 gigs, and you're only using 20 gigs inside that, you only actually pay for the 20 gigs that you're using. So that was storage. So my next scenario, extending your infrastructure. So say, for example, we have our on-premises data center, which a lot of us do at the moment, and we're running out of space, and we come to the decision that we either need to buy additional equipment so that we can run more virtual machines or whatever. But there is actually another option where we could take some of the services that we're using on premises at the moment and shift those out into the cloud. So the way we do that, you also need to set up our cloud storage environment. So in Azure, the three services that we'd use are virtual machines, storage, and virtual networks. And then in order to actually connect the two together, we can set up a VPN connection between our on-premises environment and our Azure storage, or our Azure cloud environment. So in effect, creating this VPN connection is like adding another branch site to your company. You can actually take your addressing schema that you're using at the moment and just create a new subnet out in Azure that, for all intents and purposes, appears like one of your offices. So in addition to the site-to-site connection that you can set up between your environment and the Azure environment, you can actually set up a point-to-site connection as well. So what this allows you to do is to give specific remote workers direct access into your Azure hosting environment if you wanted to do that. One of the reasons you would do that is if you're using Azure as a dev test environment and you don't necessarily want to join it to your network just yet, you can give your developers direct access into that environment so that they can play around with it if necessary. So yeah, there are two VPN options in Azure to connect into your environment. For the site-to-site VPN connection, the current device support is listed on the slide. All the usual ones you'd expect from Cisco, Juniper, Citrix, F5, pretty much a good list of all the standard devices that you'd encounter in a corporate environment at the moment. And that bottom one, you can even use Microsoft's routing and remote access service in Windows Server 2012 as your VPN access point as well. So back to the question of high availability. Obviously, if you're moving your workloads from on-premises out to the cloud, you need to be quite trusting that it's sort of not going to fail and it's going to be working as much as you need it to work. So we've already covered the issue of high availability regarding storage, where every copy of data that you send up to the cloud, 3 additional copies get created for it, and if you geo-rep, a further 3 gets created. But what about the virtual machines themselves? So obviously, if you've got a service that you need to make highly available, for example, a SQL mirror set, SQL A and SQL B up there, you want to make sure that they're not put in the same fault domain. So, for example, we have 3 racks, which could be thought of as fault domains. So because they have a piece of power or power supply in the rack or a network switch, if any one of those fails, the entire rack could go down. So this is the scenario that we really don't want to happen. If we're deploying 2 virtual machines out into Azure, we'd want to make sure that they're not put into the same fault domain, because if they are, the entire service could go down if that one fault domain goes down. So Azure actually has a pretty cool feature called availability sets, which you can use to instruct the Azure Fabric to make sure that each of the members of that availability set is actually stored in a separate fault domain. So if one of the domains goes down, we do have the other member of the availability set will be sure to be up. So expanding that out a bit further, for a web service environment again, if we had 2 web servers and 2 SQL servers that we want to make highly available, we would create one availability set for the web servers, one availability set for the SQL servers, so that we know there'll at least be one member in each of those sets up at any time. So what we've done at Provoke, as I said before, we've used Azure infrastructure quite extensively in-house. One of the key things we found that it's good at is in replacing your DMZ. So any machines that you'd usually have in the edge of your environment where you're controlling access from the internet, it's a pretty good option to actually just use your Azure environment to do the same thing. So we've currently got our ADFS servers deployed up in Azure, which means that because we are highly reliant on them for the likes of Office 365 services, and we have branch offices around the world, we really need to make sure that our ADFS infrastructure is rock solid and up all the time. So we can't afford to host it on premises at our data center, and we have an earthquake in Wellington or something, and it all goes down and no one can do anything. We also use TFS, that's Team Foundation Server, if you don't know what that is, to allow our customers access into our source control environment. We use Azure also as a SQL DR site. So one of the cool new features with SQL Server 2012, with the always-on high availability groups, is you can have multiple secondary replicas. And a pretty cool thing to do is to put one of those replicas out into Azure. So in effect, you're having a continuous streaming backup from your on-premises environment into an Azure environment. And if your on-premises environment goes down, you have a complete set of data out in Azure, and this just happens automatically. We also have a SharePoint extranet in our Azure environment. So again, to allow our customers access into our SharePoint environment rather than having to come through a reverse proxy with all the metadata to set up into our environment, we just give them direct access into our SharePoint extranet sitting out in Azure. And also our direct access servers are out there as well for the same reason that our ADFS servers are out there, to allow our international offices easier connectivity into our environment. So my second demo, I'll just give you a quick overview of building an Azure virtual network and a virtual machine.
Just a quick question.
Yep.
On your previous slide, those are all virtual machines that you're running up here, or are you using PaaS instead of serverless?
So the question was, for all these services that are listed on this slide, are we using the infrastructure as a service Azure offering or the platform as a service offering? For all of these, we're actually using infrastructure as a service because they're specific worker roles that we need to provide out there. So it'll be hard to actually run that specific software using platform as a service.
Are there a SharePoint interface?
Yeah, as well. So yeah, I mean, for SharePoint, you could use Office 365. SharePoint Online is a pretty good option. But if you do want to have the capability of SharePoint on-prem, but just have it publicly available, it's a pretty good idea to use Azure as your DMZ, essentially. All right. So we head back into our Azure Management Portal, where all the magic happens. So to set up a new virtual network to house all of our services and to connect back on premises, we just go New, Network Services, Virtual Network, say Custom Create, and we're asked for a name for it. So let's call this TensNet 11. Here's our affinity group question again. So where do we want this network near to other services? I'm going to stick it in the affinity group I created before. Go next. Then we have an option to enter some DNS servers into here. So if we're going to be connecting this Azure network back on premises over our VPN connection, we can actually put our on-premises DNS servers in here so that any of the machines on the network will be able to use your on-premises DNS servers for name resolution. These two checkboxes, so the first one at the top, configure point-to-site VPN, that allows us to essentially use certificate-based VPN connectivity and give those out to any users that we want to connect directly into our Azure environment. Other option at the bottom is the site-to-site connectivity, which allows us to download a script essentially to run on our perimeter firewall, which will allow us to set up the VPN connection to go site-to-site. So I'm going to leave all that blank for today. And then we get to specify our addressing range. So as I said before, you can essentially think of your Azure data center as just another branch office or another one of your data centers. So whatever IP addressing schema that you're currently using, you can actually map out into Azure as well. So you can see we can select our address space, anything in 10 network in 172 or 192. Leave it at 10. Let's set the CIDR address count. And then out of that big address space, we can carve out subnets if we want as well. So I'm going to leave this one called subnet 1 on the 10 network, and I'm going to give it a subnet mask of /24 to keep things easy. And you can see that we have an addressable range of 10.0.0.0 to 10.0.0.255. So we can deploy virtual machines in that network using that addressing range. Whatever fits in with what you're currently using. So from that, I'm just going to go OK. And Azure will go ahead and create that virtual network for me. But again, here's one I've set up before, just to save some time. So now that we've got our virtual network set up, we can stick some machines on it. So again, I can go back down and go New, Compute, Virtual Machine, from Gallery. And I get to choose any image that I want to deploy this virtual machine with. So there's some pretty cool options in here, everything from sort of standard Windows Server 2012 data center, you can see at the top. We've got an R2 preview, if you want to deploy that and start playing with 2012 R2. Even got a SharePoint trial, so you can deploy a SharePoint server with the binaries already installed. All you need to do is get in there and configure it. We have some SQL Server 2012 images, 2014 even, if you want to start playing with the new features there. Down to regular 2012. BizTalk servers, Visual Studio, if you want to deploy that image, and even some Linux distributions. So for today, I'm just going to choose the one at the top, Windows Server 2012. Give them a virtual machine a name. So let's call this VM10's demo, whatever. And then have options of sizes. So we have everything from an extra small VM with a shared CPU core and less than a gig of RAM, right the way up to 8 CPU cores and 56 gigs of RAM. So you can choose which scaling level you want to use for your VM. And this is changeable as well afterwards. So if you want to sort of start small and then reassess your needs as you go on, you can absolutely do that. So I'm going to select a small size, new username, password. Go next. It asks us to create a cloud service. So a cloud service is essentially just a container for VMs, and it's sort of the public face of the virtual machines inside there. So since I don't have one at the moment, I'm just going to tell Azure to create me one. So my cloud service name is just the same as my VM name. Region or affinity group. So like before, we could select an affinity group of the one I created before to make sure that this service is stored close to other services in the Azure Data Center. Or I can select a specific region I want it in. But for this demonstration, I want this machine on the virtual network that I just created. So I'm going to choose 10's net 11. And then subnet options. I only created one subnet out of the addressing range earlier. So that's my option over there. And then storage account. So I can get Azure to automatically create me a new storage account to host the VHD for this virtual machine in, or I can use one of the storage accounts I've previously configured. So I'm just going to use 10's demo 1 as my storage account. And then here's the availability set question. So since this is only a single machine, I don't really need to put it in an availability set, and I don't really care if it fails or not. But if you're deploying multiple machines and to set up a high availability scenario, you would absolutely want to put them in an availability set. So I'll leave that as none for the moment. Go next. And then I have options for public endpoints. So you can think of these as the sort of network address, port address translations on our external firewall. So by default, we're prompted to create a remote desktop access point and a remote PowerShell access point. If we're never going to be using remote PowerShell against this machine, we can easily enough just delete that. You probably want to leave remote desktop there, otherwise you won't actually be able to connect into your machine publicly. If you want to increase security on that, you can remove it if you have your site-to-site VPN connection set up, in which case you can connect to your virtual machine over the internal IP address, which you've just assigned it. If this machine is going to be used as, say, for example, a web host, I can add an extra endpoint in here for HTTP which would map public port 80 to private port 80 in the inside of the network to allow the HTTP traffic to come through. So now I can just click OK, and it'll go ahead and create that VM for me on the network I specified. So because that could take a little while, again, here's one I prepared earlier. And if we go into the dashboard, you can see some performance stats of our machine. Should come up in a second. So see, it's doing pretty much nothing at the moment, but you get some pretty interesting stats out of that. And you can see if if the current scale that you've got for that machine is working for it, or if you need to scale it up. You see at the bottom here, disks. So these are the VHDs that are attached to this machine, and a bunch of other information about it. Endpoints along the top. So here are the endpoints that we set up before. And then if you click connect at the bottom, a RDP file gets downloaded, which you can choose to open. And we just log in with the admin account that we set up before. And you'll see from that, it's just a regular RDP connection, opens up a remote desktop window, boom, you're inside the machine once it gets there, and you can pretty much do whatever you want with it. So that was end-to-end setting up virtual network and virtual machine in Azure. Any questions on that? You've probably all seen that before, but thought I'd cover it. Question over there? Oh, sorry, could you repeat that? No, we don't at the moment, unfortunately. I think that's right. Yeah. So yeah, I think that's that's been mentioned and asked for before, but we'll probably get there in the future. But for the moment, there's only a single administrative access, to the actual control panel. Sorry, Joe.
So you can monitor the store. So if you're using operations management, there's like Azure management thing, so you can monitor your VMs on Azure just like you do your management VMs.
Yeah. Yes. Yes, that's a viable alternative than connecting into the management portal. So onto my third and final scenario, expanding your reach. So this is a pretty interesting and key topic for us down here in New Zealand. If we have companies here, sort of headquartered in New Zealand, we usually tend to have a lot of infrastructure sitting down there at the other end of the world. If we have customers or other branch offices around the world, say for example in Australia or Europe or the US, it's quite a mission for them to actually get to that data, and then they run into all sorts of issues around latency and just quality of service of your service that they perceive. So it's not ideal to serve everything out of New Zealand if you have a global reach. So obviously, because of the scale in Windows Azure, we have data centers all around the world. So if you have customers in the US or wherever, you can actually deploy a copy of your service out in each of those data centers to make sure that it's close enough to where your customers or employees are, just to make sure that they get some good level of service out of that. You can also deploy a customized version of that service tailored to that local environment. And again, because you're dealing with Azure, it's the same interface whether you're deploying it in Singapore or the USA. You don't need to go out there looking for another cloud provider who perhaps may not be in the region that you want to be in. So yeah, the benefit of that obviously is Australian users can access the data center in Singapore, and the other users around the world can access their respective data centers. So taking service to your users, a couple of examples. You can build websites with global scale. So if you have, again, you want a tailored website to your US audience or UK audience or your Asian audience, you can deploy an Azure website using the PaaS option even to make it really infinitely awesomely scalable, and deploy that to data centers close to where your users actually are and where they're going to be using your service. You can deploy local servers for international offices. which makes a lot of sense if you want to keep a large amount of data close to where users are, rather than them having to go over the internet, collect it from New Zealand and bring it all the way back to them again. And you can also improve the performance with Traffic Manager. Traffic Manager is a pretty cool feature in Windows Azure, which has been around for a while, but has only recently been available to access through the App Management portal. So I'll give you a quick demo of that. So you can think of Traffic Manager as essentially a intelligent load balancer, where a regular load balancer would generally just sort of do round-robin balancing. If you have different endpoints to connect to, it would load balance across those endpoints in the environment that you're in, whereas Traffic Manager allows you to essentially load balance across endpoints, even in different regions. So to illustrate that, I have created 3 cloud services, essentially just virtual machines running IIS. So you see I've created a TENS demo Asia, TENS demo Europe, and TENS demo USA. And you'll notice the location of each of them. The Asian one is obviously stored in the Southeast Asia data center. Europe is stored in Western Europe, and US is stored in the US. And we have our public URL, which we can use to access these. So I'm going to show you the Asian one, TENS demo Asia.cloudapp.net. And it takes us to an Asian version of our website. If we go to TENS demo Europe, we have a European version of our website. Likewise for the States, TENS demo USA. And we have an American version, so 3 separate versions. Say, for example, though, we want to go public with an address that everyone can use, but we want to make sure that they're directed to the website that's relevant to them. We can actually easily do that with Traffic Manager. So we can head down to Traffic Manager on the left-hand side and go, new, quick create, and DNS prefix. So this is essentially going to be our public DNS name for our service. So we have to call it something .trafficmanager.net. So for example, let's just say TENS demo 99, trafficmanager.net. What we can do, though, is create an additional sort of public vanity DNS name and use that as a CNAME to this address. So you can still use whatever name you want, but in DNS, it'll just CNAME resolve to our Traffic Manager address. And you'll see we have an option for load balancing method. So we've got 3 options, one for performance, round robin, and failover. The performance one is the cool one, where the Azure stack would actually know or recognize where you are in the world and actually sort of pings the data centers around you for the options that it has to actually load balance this traffic request to, and it sees which one gives you the most performance. So, yeah. So, for example, in our service endpoints at the bottom, I can select the 3 VMs that I created earlier, and then create. And what that will allow us to do, here's one I created earlier called TENS demo. You'll see that if we go to the public URL for this, tensdemo.trafficmanager.net, and I paste it in and go enter, it'll take us to the Asian data center version of the 3 options it had, because Azure notices that I'm closest to the Azure data center, so I'd likely have the best performance out of that region. So I mean, you can see for yourself, what some pretty cool options that you could do with Traffic Manager. There are another 2 options for load balancing as well. So that was the performance option. There's also round robin and failover. So round robin, as you can imagine, every new user that comes along, it'll just direct them to one of those sites. And then failover, if Azure will actually monitor which of those sites is up, and if someone tries to access one that's down, it'll just fail over to one that works. So that was Traffic Manager. Any questions on that? No? Yep.
So if you're using the performance kind of failover, what happens if one of the servers is kind of taken offline? Does it go to the next closest one? Or
question. The question was, if you're using the performance failover method and one of the service endpoints that are available goes down, will it take you to one of the other ones? I think it would. I'm not 100% sure on that, but would you know, Darren? So the question was, in using the performance failover method of Traffic Manager, if one of the endpoints went down in that, would it automatically fail over to the next one that's available? Yeah, so I'm pretty sure we'll just go to the next one in the group. Yeah, it's free at the moment as well. So there's no charge to use the Traffic Manager service. All right, so nearing the end of the presentation. So I'd like to just sum up and tell you why, again, Windows Azure is a pretty good choice of cloud service provider, especially if you're already using the Microsoft stack. Reason number one consistent platform. So no matter what you're doing on premises or in the cloud or in a service provider location, you get the same experience. It integrates with what you've already got, so you don't need to throw away anything you've got at the moment to use cloud services from Azure. It just works and slots in. Thirdly, they're financially backed SLAs. So Microsoft really stands by what they say. If your service goes down for any longer than what's specified in your SLA, you actually get credit back on your Azure account. Fourth, enterprise-grade support options. So you're not just left out there wondering what to do if something goes wrong. There's a standard level of support for everyone who uses Azure, but if you want more support or faster support, there are actually other options that you can use, pay a little bit extra, and you get much higher levels of support out of the Microsoft support centers. And lastly, you get to work with a provider that you already know. So I mean, most of us would probably have enterprise agreements with Microsoft already. We're using a lot of Microsoft products. We're familiar with how Microsoft works. We've engaged with them before. So it's really sort of trusting your critical workloads and your sensitive data with the company that you already know, how they use it. And you know that they'll be there to help you out if you need a hand. So yeah, takeaway for today, I'd really like you to go ahead and make Azure your data center. You've seen a few options of how Provoke's used it today. There's a lot of other stuff you can do with Azure, so please go ahead and have a play. There's a free 30-day trial available at windowsazure.com. You get 260 New Zealand dollars to spend however you want. You can build up a VM, store some stuff out there, use Traffic Manager, use websites, whatever you want really. So just go ahead, have a play for 30 days, see how it can fit into your environment, and yeah, use Azure as your data center. Some related content. If you want to know more about Azure, there is a session directly after this deploying Minecraft server on Windows Azure, which is a pretty cool thing to see. You get taken through everything from the initial setup of your Azure environment to actually using Minecraft server in production. So if you want to go over the whole setting up networks and VMs and things again, please go ahead to that one. It's going to be a cool session. Ben and Jaron did a session on Store Simple yesterday, so that should be online fairly soon, if not already. So if you want any more information about Store Simple, a bit more of a deeper dive, please go ahead and see that on the TechEd website. Yeah, it's a pretty good session, so have a look at that. And if you want to have a chat to me about anything Azure related, I'll be in the hub later today. See me around, have a chat, and yeah, we'll help you out any way we can. Standard slide, please evaluate this session. You can win some cool prizes. I appreciate any feedback you have for me as well. How good or badly I did today, let me know. And that's about it. So, were there any other questions at all? No? Sorry, yep. Okay, come chat to me after. All good.